Hi students. Okay, I hope all of you are doing good. So in our last revision class, we were doing questions on reaction mechanism. So we will continue from there. Okay. So all these questions are very important actually for this NEET exam, and you know that. So all the questions are directly taken from NCERT. It is NCERT based. Okay. So my name is Riaz. I'm part of Brainiacs family, and see, it's a reaction mechanism part 3 video, and those who haven't seen the part 1 and part 2, you please subscribe Brainiacs YouTube channel. You can go to the playlist. There you could see the part 1 and part 2 videos in the playlist, and other chapters as well. Okay, surely it will help you to score a very good score for NEET exam. So let's start with the question. So I hope all of you could see the question. So, question here is the correct statement. The correct statement regarding an electrophile is. Okay. The various statements are mentioned. The first one, what they have mentioned is electrophile is a negatively charged species. Okay. And it can form a bond by accepting a pair of electrons from another electrophile. This is what they are telling. Second one, electrophiles are generally neutral species. Okay, and they can form a bond by accepting a pair of electrons from a nucleophile. Now, if you see the third statement, electrophile can either be neutral or positively charged species. So it can form a bond by accepting a pair of electrons from a nucleophile. Fourth one, electrophile is a negatively charged species, and it can form a bond by accepting a pair of electrons from a nucleophile. So let's try to understand what is an electrophile. That will give you a complete idea how to attend this question. Okay. Yeah. So we can classify. Where does the electrophile fundamentally come, sir? That is very important. Electrophile, it's a type of an attacking reagent. I can say it's an attacking reagent. So you should know how the attacking reagents are classified. So attacking reagents are classified into three actually. One is electrophile, next is a nucleophile, and the third one is a free radical. Okay. So what is fundamentally an electrophile? From the term itself you will understand. Phile means love. Electrophile means electron loving. That is what it means. So that means electrophile is a species which loves what? Electrons. Clear? Now, if it is loving electrons, that means electrons are negatively charged, correct? So that means electrophile have some charge opposite to that. Then only it can attract this negatively charged electrons. Then I can easily say electrophiles are usually, it can be further classified into two. That is, one is a charged electrophile, and electrophile usually have the charge that is positive in nature. Then only it can attract negative charge. And the other one is a neutral electrophile. Then students will have a doubt, sir, why then neutral electrophile will attract electrons? We will try to see that. Okay, so we can say that electrophiles, they are positively charged species. Okay, and all carbocations are electrophiles. What is fundamentally a carbocation, sir? Carbon carrying positive charges. So we can see that in a carbon carrying positive charge, there is a vacant orbital, or there is a deficiency is there, or I can simply say carbon has positive charge. If any species has a positive charge, usually it will behave like an electrophile. Okay. Now let us see the famous electrophiles. Nitronium ion, NO2 plus, Cl plus, chloronium ions, and CH3 plus. You can see carbon with positive charge. So it's a carbocation also. Okay. So fundamentally what then electrophile will do? I can say the other class of attacking reagent, that is a nucleophile, is just opposite to it. Because nucleo means nucleus, phile means loving. So that means they love nucleus. Nucleus is what charge? Positive charge. So I can say nucleophile is some species which loves positive charge, which is loving positive charge. That means nucleophile itself is what charge? Negative charge. That's why it is loving what? Positive charge. Okay. So nucleophiles are also similarly classified into two. We can say neutral nucleophiles and charged nucleophiles, that we will see in some other session. Okay, so I can say usually electrophiles, they are electron deficient, or they love electrons, so they usually accept the electrons from whom? Nucleophile, because nucleophile is negatively charged and they are ready to donate electrons. Okay, so we can say electrophiles, they accept electrons from the nucleophile to complete its octet. Now let us try to understand some neutral electrophiles that usually comes for the exam, because there won't be no positive charge, so students may get confused whether it's an electrophile or not. So it's the best thing that you need to do here is check for the octet. For example, I can say aluminum trichloride. It's a very famous electrophile. If you see the number of electrons around this aluminum, you can see 1 2 3 4 5 6. So usually 6 electrons are present around the central aluminum atom. So it needs 2 more electrons to complete the octet. This is the one reason why we say aluminum trichloride is an electrophile, or we can say the central atom is electron deficient. Clear? Now we have some peculiar type of electrophile, something like a carbon dioxide. Most of the students doesn't know carbon dioxide is an electrophile. Why? Because when we check the carbon dioxide, we see around carbon, we can say, for example, okay, so let's check it like this. If you are seeing the number of electrons around carbon atom is, you can see here 4 5 6 7 8. In one stretch we see 8 electrons are around carbon atom. But please understand, whenever an atom shares a multiple bond with an electronegative element, what will happen? What will happen? This electronegative element, like oxygen, has a tendency to attract the electrons. So, and this multiple bond or pi bond is a weak bond, we know that. So what will happen? This pi bond undergo polarization and it will shift towards the oxygen and it will become negative charge, and the carbon will acquire a positive charge. Now you check the number of electrons, 2 4 and 6 electrons. I can say this carbon is temporarily behaving like an electrophile, and that is the reason we say carbon dioxide is a temporary electrophile. So don't forget this is very important. Okay, so next what we are going to see is a very important electrophile that is called a dichlorocarbene. This is something a very famous electrophile in Raymer-Tiemann reaction. So in dichlorocarbene also, if you see the number of electrons around the carbon atom, and it is numbers total 6 electrons are present, so it needs 2 more electrons to complete the octet. Okay, so this is a very famous electrophile. Now read the statement. Now go to the question and read the statement. I can easily say third statement. If you read it, you can see electrophile can be either neutral or positively charged species. Correct? We know that. And it can form bond by accepting a pair of electrons. Accepting a pair of electrons from a nucleophile. Correct? From nucleophile only it can accept electrons. So I can say my answer here would be which one, sir? So I can easily say my answer here is option 3 would be my correct answer. Clear? I hope it is clear for you. Okay. Now let's try to understand the next question. Okay. Okay. Go through the question. The question here is again with respect to acidity. So they are asking which one is the correct order of acidity. So if you look at generally, we can see there is alkenes are there, alkenes are there, and alkanes are there. So how will you compare the acidic strength of alkynes, alkenes and alkanes? Very easy to understand. So here we take into consideration the hybridization, very important. Okay, so what is the test fundamentally we do to check whether a compound is acidic or not? We will release the H plus from that. Okay, so here we are releasing the H plus from the triple bonded carbon. Why? Once the H plus is released from here, this will attain, this hybridization of this carbon is very important to understand. Okay, here the carbon has sp hybridization. Okay, here the carbon has sp hybridization. Why? That also I have told you. You don't need to consider pi bond into consideration. There is one sigma bond and there is a negative charge. So totally 4 electron pairs. Whenever 4 electron pairs are present, it is sp hybridization. 2 electron pair for S, 2 electron pair for P. So that is sp hybridization. Okay. So what is the peculiarity of sp hybridization, sir? Can anybody tell? I can say in sp hybridization, I have already discussed this in my previous videos. You can see that here in sp hybridization, the percentage of S character, is 50%. I can say 50% S character. That means that particular carbon has more electronegativity. Why? As the S character increases, its approach towards the nucleus is very close. That means it will attract electrons very easily. So I can say it has more electronegativity. And what it will do, so it will attract this negative charge towards it, and it will try to decrease the charge density on the carbon. So if the charge decreases, what will happen, sir? Charge is decreasing, stability increases. I told you many times what we fundamentally do during acidic strength test: remove the H plus and check the remaining structure is how much stable. If the remaining structure is stable, it will not call back your H plus. So very important. If this structure is stable by some means, for example by resonance or by inductive effect or by hybridization, I can easily say the corresponding compound is highly acidic in nature. Clear? Okay, and here we need to compare two species. Here this species also have triple bond, but so here also it is stable, but one difference here is there is a methyl group attached to here. Methyl group. What this methyl group will try to do, it will push the electrons in this direction through plus I effect. I can easily say electrons will move in this direction. So if electrons are moving in that direction, it will increase the charge density. So I can say comparing this one and this species, or comparing this species and this species, this would be more stable. Why? Because there is no plus I effect of the methyl group here, but this has plus I effect of the methyl group. That will make this compound a little unstable. So I can say this is highly acidic compared to this terminal alkyne. Okay. Now coming back to second type of compound, that is an alkene. In alkene's case, if you remove the H plus, you will get a compound, but here you can see the hybridization that is present here. You can see here one sigma bond and there is another sigma bond hydrogen, and there are two electron pairs of negative charge. So totally 6 electron pairs are there. The hybridization would be sp2. So I can say sp2 has less percentage of S character. Less percentage of S character means it will attract the negative charge lesser compared to an sp hybridization. So that's the reason why we say its acidic strength is, it is not at all acidic, or it is a very less acidic compound. Okay, then comes finally our alkane. In alkane's case, the hybridization is totally sp3, which is not at all very less electronegative. So I can say it is not at all acid actually. So what would be our best order? Can you tell? So I can say highly acidic compound is this one, ethine, then comes this one, prop1 wine, then ethene, then only alkane will come. So my answer would be option 1 would be my correct answer. Any doubt? I hope it is clear for you. Okay, very important question, directly mentioned in NCERT. Okay. Okay, so I hope students you are preparing well. So please continue your preparation. If you have any doubts or any support you require for a particular topic, please put it on the comment box, especially on the chemistry. And we also have physics revision running parallelly. You can also watch that videos. It would be highly helpful for you to score a very good mark in NEET exam. Okay, so let's try to see the next question. This is also very important. Okay, we need to find the acidic strength of the following 4 compounds, and we need to identify which one is more acidic. Okay, so here also what is the step, sir? You need to tell me. We need to identify the hydrogen which is attached to the electronegative element. So we can understand easily say the hydrogen attached to oxygen is highly electronegative element is the oxygen. So what we need to do, remove it as an H plus and compare the stability of the remaining structure. That is what we are supposed to do. Okay, so let's try to see. So from first compound with OH, I can say this is phenol. Okay, this is phenol, and we are removing the H plus. So we are getting something that is called phenoxide ion. This is called phenoxide ion, and we know that if you see the phenoxide ion structure, we can easily say this is stabilized via resonance. Why? If you see here, negative charge, single bond, double bond, single bond, double bond, single bond, double bond. So there is conjugation present. So what we'll do, we have learned that whenever a negative charge is in conjugation with a double bond, what will happen? Negative charge will move towards the pi bond. So this will move towards here. Then this carbon will have 5 valency. So it will repel this pi bond to here. So you will get a double bond here and a negative charge here. But it is not stopping here. Why? Because negative charge, single bond, again double bond. So negative charge again will move towards a pi bond like this. Then here this carbon will have 5 valency because hydrogen is already present. So this will move towards here as a negative charge. So you will get this particular structure. Okay. Again, it is not stopping. Why? Negative charge, single bond, double bond. So negative charge will move towards a pi bond. Again, this carbon will have 5 valency. So it will move towards here as a negative charge. So you will get this particular structure. So what will happen next? Then again, it will move towards here. Then this will come back here. And this is the final structure. And what will happen again if you are drawing a next structure? You need to again come back here. Then it will come back here. That is this structure itself. Okay, so I can say it is stabilized by 5 resonating structures. 5 resonating structures. Now let's try to see the next one. In the next one, you can see there is a nitro group is attached. What is the impact of this nitro group here? Very important. So what this nitro group do here is, whenever the negative charge is coming here, you can see here negative charge coming here, is this negative charge can enter into resonance in 2 ways, either with this pi bond or it can enter into resonance with this pi bond. So that means it is giving you an additional resonating structure. Okay, so this is giving you an additional resonating structure, or we can explain it in another way. NO2 group have minus I effect. So this minus I effect will pull the electron in this direction and decreases the charge density. I can say the charge density decreases more in this particular resonating structures. Why? Because of the minus I effect of the NO2 group. These two things will make this particular structure more stable compared to the phenoxide ion structure. So I can say para-nitrophenol will be more acidic compared to phenol. Okay. Now with this logic, you can see this particular compound. You can see at ortho position there is a nitro group, para position there is a nitro group, and there is again back at ortho position there is a nitro group. So that means once you remove the H plus, this particular structure is stabilized more. Why? Because every time it is coming into this one, all these structures are giving you an extra resonating structures. You can see whenever it comes to ortho position, there is a structure here. It comes to para position, there is an extra structure here, and whenever it is coming to again at ortho position, there is another extra resonating structure here. And also the 3 NO2 groups is pulling the electrons in such a way that this have very less charge density in the oxygen atom, so it will not attract the H plus very fast. So this is highly acidic. We can call this as 2,4,6 trinitrophenol. Very important. This is something called picric acid, highly acidic compound. Okay, I hope it is clear for you. So from this itself we can tell what is the answer for this particular question. So the answer would be option 3 would be my correct answer. Okay, I can mark option 3 as my correct answer. Okay, I hope it is clear for you. Any doubt? Yeah, so I have put it in detail all the resonating structures. So I will also upload these notes after we have completed the revision. Okay, here for your comparison I have given the last option also. In the last option we can see a difference. The group that is connected here is a methyl group, and this guy have plus I effect. From that itself I can understand this will repel electrons in this direction, and the charge density here increases. If the charge density is increased, what will happen, sir? Tell me, sir, what will happen? It will attract the H plus. So whatever H plus it has released, what it will do? It will attract the H plus very fast. So I can say this guy is even less acidic than phenol. Why? Because phenol doesn't have CH3 group. You can see here in the resonating structures, here CH3 group is coming and this is pushing electrons in this direction so that the charge density is increased. This is the most unstable structure among all the resonating structures. Okay, I hope it is clear for you. Okay, then we have the next question. All of you please go through the question. Now we are coming to the basic strength. Okay, the correct increasing order of the basic strength for the following compounds is. That is what the question. So first compound that is mentioned here is benzene with the NH2 group. And what you call, sir? Benzene with NH2, and this is called aniline. benzene with NH2 is called fundamentally aniline. Then you have para-nitroaniline, then you have para-methyl aniline is present. Now we need to compare the basic strength. So basic strength is just opposite of acidic strength. Why? Because in a base, what we are considering here is the availability of lone pair in a particular atom. Or this lone pair, what it will do? It will attract the H plus. So basic, how a compound is considered as basic. Basic means three definitions are there. Either it is capable of attracting H plus, or it is capable of donating OH minus, or it is capable of what? Donating electron pair. So if it wants to donate electron pair, this lone pair should stay here. Or if it needs to attract the H plus, the lone pair should stay here. It should not move. So we will analyze with this understanding. Okay. So we can see here this lone pair. We can see lone pair, single bond, double bond. So there is a resonance here. So surely I can say this lone pair will move towards the benzene ring, and this lone pair is in resonance. So if it is in resonance, I can easily say H plus will not get attracted that easily to nitrogen, because there is no lone pair is not localized here. If it is staying here, surely this will create an electric field and it will attract the H plus very easily. But this is moving means it cannot attract the H plus very fast. Okay. Now we need to compare anyway this type of compound. Now this is aniline I have taken. Now in the next species we have the nitro group is present, sir. Nitro group is present. What nitro group is doing? Again this has minus I effect, so it will attract the electron pair or negative charge very fast towards its side. So again here more deficiency is coming, or I can say here deficiency will appear very fast, or it has very less capability to attract H plus. Now if you see the next structure, it has a CH3 group here. We know that CH3 group have plus I effect, but it is doing the reversing. It is pushing the electrons in this direction, and somehow it is increasing the electron density of the nitrogen. So I can say this is a good base. Why? Because it is pushing the electron in this direction, and H plus can easily come over here. Okay. So what would be my respective orders, sir? So here I have mentioned all the three contains amino group. The lone pair present in NH2 group enters into resonance in benzene with all the three cases. However, in option B, the NO2 group has minus I effect, and it decreases the availability of lone pair to a great extent compared to aniline. And in the third structure, we can say the CH3 group at para position increases the electron density because of the plus I effect of the methyl group. So I can say highly basic would be C, then comes A, okay, then comes A, and then comes B. Okay, so my order would be CAB, CAB. Okay, so what is the important tip you should remember? What is the important tip? Increasing the electron density increases the basicity. Why? Because it will attract the H plus very fast. As base is either a good electron pair donor or he is a good H plus acceptor. Both are same. Electron pair it should be able to donate, or with that electron pair it should be able to accept what? H plus. You can consider both definitions to do this type of questions. Okay. Now again we are getting back to attacking reagent. Very, very important. The question here is, which of the following statements is not correct for a nucleophile? So tell me, sir, what is a nucleophile? We already seen that. So nucleophile means nucleus loving species. Nucleus loving means they are loving positive charge. So they themselves are negative charge or neutral in nature. So I can, first statement, let us understand. Nucleophiles attack low electron density sites. It's very clear. Correct, right? Why? Because low electron density sites means they are electron deficient area. So nucleophile is a species which is ready to donate electrons to this particular area. So I can easily say this is a correct statement. But in the question they are asking which is not a correct statement. Okay. Nucleophiles are not electron seeking. That is also correct. Nucleophiles are ready to donate electrons. So that means they are not electron seeking. Electron seeking means electron loving. They are not electron loving. They are nucleus loving or positively charged, positive loving. Okay. Nucleophile is a Lewis acid. That is a wrong statement. Why? Because Lewis acids are electron deficient species. They are electron deficient species. So electron deficient species means what? It should be an electrophile. I can say electrophiles are Lewis acid, and nucleophile is a Lewis base, I can say. And ammonia is a nucleophile. Of course, ammonia, if you see NH3, we know that nitrogen has lone pair, and this lone pair is an electron rich area, so it can donate electrons. So my answer here would be option 3 would be my correct answer. Okay, so I have given you ample explanation here, don't worry. So here we can say nucleophile, how it is classified. It can be neutral nucleophile or a charged nucleophile, and you know that charged nucleophile means nucleophiles are negatively charged. Okay, and neutral nucleophile means those nucleophiles which does not have a negative charge but always will have lone pair present in it. You can see all these species, if nitrogen, oxygen, halogen, these elements are present, surely it can behave like a nucleophile. Why? Because these species will have lone pair and this can be easily donated. That's the reason why these species will come under neutral nucleophile list. Okay, so we can say charged nucleophiles are negatively charged species, and all carbanions means carbon carrying negative charge, they are nucleophiles. Okay, and the nucleophiles, they attack where they want to go to, or they will go to a place where electron density is low, or we can say low electron density sites. And nucleophiles, what it will do, sir? It will donate electrons, and nucleophile is a Lewis base. Clear? Okay, this is a very important tip. All neutral nucleophiles, they possess lone pair of electrons. We have seen that. These are examples of charged nucleophiles. You can see Cl minus, Br minus, I minus, F minus, CH3 minus, RNH2 minus, OH minus. So negative charge is present. I can easily say it's a nucleophile, charged nucleophile. So next comes the very important question. Let me zoom out for you to see the question in complete. Okay, then also it's difficult. Okay, yeah. Okay, if you require, you can take a screenshot. It's a very important question. It's an indirect method of asking acidic strength actually. Why? You can see a compound that is what I can say artificially made. And they are asking when this particular compound is treated with NaNH2. This particular compound is treated with the NaNH2, what will happen? Many of the students will say, sir, we haven't learned such a reaction, sir. Is this out of syllabus? No, of course not. Please understand, we are treating with the NaNH2 means it will split like Na plus and NH2 minus. Now I can say this is a reaction where this particular compound is reacting with a metal. We know that those acidic compounds, acid react with metals to form salt and it will liberate hydrogen. So indirectly they are asking, out of these 4 compounds mentioned here, which is more acidic, and that particular structure will react with the Na plus and it will liberate hydrogen. Correct? So it's a very important. They are asking you whether phenol is more acidic, or benzyl alcohol is more acidic, or alkyne is more acidic, or even benzoic acid is more acidic. This is what they are asking you indirectly. So they can create this compound in n number of ways. This is one simple example I am showing. Okay, so when we are comparing the acidic strength, please listen. So fundamentally is very simple. We know that acids react with the metals. Acids react with the metals to liberate hydrogen gas. So acid with metals gives metal salt and hydrogen gas. So if you compare the acidic strength of the given compounds, I can easily say benzoic acid is more acidic. Okay, because the benzoic acid, when it forms the carboxylate anion, this is stabilized, highly stabilized structure. Why? Because it has equivalent resonating structures. That's why benzoic acid is more acidic than phenol, which is more acidic than benzyl alcohol. Then comes alkyne. You need to remember this order. Okay, so you can remove the H plus and you can see here carboxylate anion, C double bond O minus. This is present in benzoic acid. Okay, I will show you that for your understanding. For example, I can show you here. Okay, suppose you have benzoic acid is present here. Let's see here. This is my benzoic acid. What will happen, sir? C double bond O minus. H plus is removed. This is the structure. Now, negative charge, single bond, double bond. So this will give rise to another structure. This is O minus and double bond O. And if you see, these two structures are identical in nature. So equivalent resonating structures are more stable compared to, even though if you have more number of phenol have 5 resonating structures, but still carboxylate anion that give rise to equivalent resonating structures. So that's why it's more stable. We need to understand, we need to learn about comparing the stability of various resonating structures. It's very important. Around 7 rules are present. We will discuss that in the coming videos. Don't worry about that. So the answer is very simple. Tell me, sir, what will happen here? Here H plus or hydrogen H plus would be removed from here and sodium will come here. So which is that option that gives you this answer? I can easily say option 4 is the correct answer. Here from H plus is removed from here and Na is coming here. Okay. I hope it is clear for you. Here also I have mentioned it. Okay. So please understand, sometimes this would be given here also. The structure they can draw it in different ways. So please understand the logic of this question and try to do it. Okay. Then comes the next question. It's also very important. Question they are mentioning is pKa increases in benzoic acid. I'm taking benzoic acid and they're telling pKa increases in benzoic acid when substituent X bonded at para position is what? So you are putting something in the para position of the benzoic acid and they are telling which of the following 4 things, if you keep it in para position, its pKa should increase. What does that mean, sir? pKa increases means acidic strength decreases. We know that Ka is directly proportional to acidic strength. Okay, and Ka is inversely proportional to pKa. So they are indirectly asking which of the following groups, if you place at the para position of the benzoic acid, its acidic strength should decrease. If acidic strength decreases means Ka decreases and pKa increases. Clear? So I hope you understood the question. Very, very important. Okay. So let's try to say, this is the concept. You should take a screenshot if you require. As Ka increases, acidic strength increases. Ka is inversely proportional to pKa. So we can say minus I effect. Okay, that is required here. Minus I effect order is this one. NO2 have maximum minus I effect, then cyanide group, then COOH, then methoxy. Okay. Now let's try to analyze each of the one. I have put it in very detail, but you don't need to do all these things for solving this question in NEET exam. This is for your understanding. Understanding the questions is very, very important actually. Okay. So first I am putting the COOH group here. Okay. So when COOH group I am placing it, you can see the various resonating structures and everything that is mentioned. And when nitro group is placed here, you can see the various resonating structures coming out of that. Okay. You can see here. Okay, you can take a screenshot because this would help you. That's why I'm keeping. Then cyanide group I am placing it. Then you can see the various resonating structures. Okay, all of them have similar resonating structures and everything. Okay, and then the methoxy group is placed. Now the easiest way to do this question, that's, let me tell you, you know the minus I effect of nitro group is the highest, correct? Then cyanide, then COOH, then OCH3. Then I can say when NO2 group is connected to benzoic acid, what will happen, sir? You have COO minus ion is there, here NO2 group is here. This NO2 group will pull the electron in this direction very easily and make the structure very stable very fast. Then that means this particular compound will have, it can release H plus very fast, or the remaining structure is highly stable, or it has the highest acidic strength when NO2 is connected. That means the group which has very less minus I effect, if it is connected there, for example OCH3, it is almost having very less minus I effect. So it will pull the electrons very less. So that will make the structure very less stable. So I can say its acidic strength is very low when OCH3 is connected. That means Ka will be very low when OCH3 is connected. That means its pKa value will be very high there. This is a simple way you can do this question. But if you need more analysis, what is happening there, you can see these resonating structures and see how the resonance is affecting this one. When NO2 group is connected here, what it is trying to do, all these things you can see here. Okay. So I have tried to put all the resonating structures and make you understand how the resonance also looks here. Okay, but without NO, because resonance is common here across all the compounds. That's why we are taking minus I effect and taking a decision. Okay, so this is the comparative acidic strength in this particular case. First, I can say, okay, sorry, I need to put the arrow in the opposite way. I put it in this way. That's wrong. So the highly acidic compound here is this one. Okay. Then comes this one. Okay. Then comes this one. This would be the respective order. Okay. I hope it is clear for you. Hmm? Yeah. So let's try to do the next question. Very, very important. Okay, the total number of contributing structures showing hyperconjugation for the following carbocation is. So they have shown a carbocation and they are asking you how many hyperconjugation structures are there. So very, very important, what does hyperconjugation mean? Another name for hyperconjugation is no bond resonance. No bond resonance. What does that mean? I will explain you. Very simple to understand hyperconjugation is whenever there is a vacancy in deficiency happens to a carbon and the nearby carbon has a CH bond present. Nearby carbon has a CH bond present. Nearby carbon is called an alpha carbon. Then the corresponding hydrogen is called an alpha hydrogen. Then this bond will displace from here to here to remove this deficiency. Then there will be no bond here. And this phenomenon is called no bond resonance. Okay. So let's try to understand. So this is the particular structure mentioned. Now I have put the detailed structure here. If you see this particular structure, you can see something. So this is the deficient carbon that is shown here. So nearby carbon, this is an alpha carbon. So nearby there is another carbon is here present. So this is also an alpha carbon. Nearby there is another carbon present here. This is also an alpha carbon. Correct? Now check out how many, this alpha carbon has how many hydrogen. This guy has one CH bond, another CH bond, another CH bond. So these three hydrogen are capable of removing its bond and forming a double bond here. Here also this have another two hydrogen available to do the same way. This also have one hydrogen. So totally I can say 6 alpha hydrogen, they are ready to form a bond here to remove the deficiency. So I can say there are 6 alpha hydrogen. So the answer would be 6. My answer would be option 1 would be my correct answer. Okay. Now for some students to understand, sir, how these resonating structures looks like, please understand this is called no bond resonating structures. So first structure I am zooming in for you to understand. See here. Here you can see this hydrogen is removing its bond and it is entering into no bond resonance. There is no bond here and forming a double bond here. Okay, similarly in the next figure you can see this structure is doing the same thing, this hydrogen. So this is the second structure. Third one you can see this guy is doing the same thing, and here you can see the fourth one, this guy is doing the same, this guy. Okay, in the next structure you can see this guy is doing. So I have drawn all the structures for you to get a clear picture. Next one, this one. So I have drawn all the 6 no bond resonating structures. So from this you can clearly get the answer as 6. Clear? I hope it is clear for you. Okay. So let's try to do the next question. So the next question what they have shown here is, see here, the type of intermediate formed in the first step of the electrophilic addition of H plus to this particular alkene is. So this is almost getting into reaction mechanisms of alkenes, but very important, we have the classification of reactions we need to learn in this chapter. That's why this type of questions are coming from here. Okay, so let's try to understand how this you need to do. Very simple, sir. We can see whenever a compound is given, this is the simple way to analyze it. A compound is given, first we need to understand where is the reaction center. We can say this compound can become reactive when any of these 4 categories are present. Whenever there is a charge is present, the compound will become reactive. That means if the compound has either positive or a negative charge is present, the compound will become reactive. Next thing is, whenever the compound, in a particular compound, if any of the atom is electron deficient means it will attract electrophile. So I can say that would be highly reactive in nature. Whenever the compound has lone pairs present in a particular compound in any of the atoms, it will attract the electrophile, then it will become reactive in nature. And whenever the compound has pi bond present, then the compound will become reactive. Why? When the pi bond is present, when the electrophile will approach here. Why electrophile is approaching? This pi bond is electron rich. So when electrophile approaches a pi bond, it will undergo polarization, and the phenomenon is called electromeric effect. So here I can say the reaction center, which is a reaction center present, sir. I can find pi bond here. So I can say the pi bond present here will make the compound reactive. Okay, the pi bond present here, 1 minute. Okay, the pi bond present here will make the compound reactive. So because of the pi bond, there is pi electrons, or I can say this is an electron rich species. So who will approach? H plus will approach here. So when H plus is coming, this pi bond will undergo polarization. Now the question is, in which direction this pi bond will move? In this direction or this direction? I can easily say it depends upon the stability. Suppose it is moving in the other direction like this, minus is there like this, plus is coming here like this. You can see here when plus is coming here, this is the alpha carbon and this is giving you only one alpha hydrogen. So I can say this is less stable. But here if you see plus charge is coming here, suppose the pi bond is moving in this direction, what is happening? This is my alpha carbon, this is my alpha carbon. So totally 5 alpha hydrogen is present, that is making the compound more stable. That is the reason why this is shifting in this direction. This is what is Markovnikov's rule also. What does that mean? The positive charge will comes to less hydrogenated carbon. Actually he is telling that with respect to this stability concept based on hyperconjugation. Okay. So I can easily say H plus will attack the negative charge because negative charge will attract positive, and you are getting an intermediate. You can easily see here positively charged intermediate is called a carbocation, and this is coming in a carbon that is connected to two other carbon atoms. So we can call this as a 2-degree carbocation, and I can easily say this carbocation is stabilized by how many alpha hydrogens, sir? This is an alpha carbon, this is an alpha carbon. So totally 6 alpha hydrogen is ready for no bond resonance, and this is highly stable. Okay, so my answer would be which one, sir? What would be my intermediate? I can easily say my answer is 2-degree carbocation is my correct answer. Any doubt? I hope easily understandable. So what things we have done? Identify the compound, identify the reaction center, check whether there is a positive charge, negative charge, lone pair or electron deficient element, or there is a pi bond. If pi bond is present, surely electrophile will come. If lone pair is present, lone pair means negative charge is already there in the compound, so electrophile will come. If positive charge is present, then only nucleophile will come and attack. Okay, try to get this understanding. Suppose if a free radical, suppose an element with a single electron is present, then that is called a free radical. Surely then who can come near to that? Another free radical can only come, then only it can form bond formation. So this is the fundamental concept in reaction mechanism. Okay, so I hope you understood. Yeah, so we have the next question. Which of the following groups contain only electrophiles are only present? So if you see here, in this particular species, negatively charged compound is present, so there is a nucleophile here. In this particular compound, water is present, water has lone pair, so that's a nucleophile, so that is not the answer. Here NO2 plus electrophile, CH3 plus electrophile, but trimethyl, so you can see tertiary amine. So nitrogen has electron pair, so surely it is not an electrophile, so the answer should be option 4. Okay, so from that itself I can say my answer is option 4 is the correct answer. Okay, so let's try to see AlCl3. I have already told aluminum trichloride. It's one of the famous electron deficient Lewis acid which is used in almost all Friedel-Crafts reactions. Okay, very very important, especially in preparing chloro compounds, chlorobenzene or any other thing. Next one is SO3. Many students will have a doubt, sir, how SO3? Please understand the structure of SO3 is like this. And please understand, I told there is a multiple bond between oxygen and this element, and oxygen is more electronegative, and this will force this to move like this, and temporarily this will attract a positive charge, and that will make this compound an electrophile. NO2 plus, easily you can say plus charge is present in nitrogen, and that will make the compound an electrophile. Clear? So I hope it is clear for you. Next one, again we need to compare the stability of carbocations. The question here is the order of stability of the following cations, or it's a carbocation, positive charge present on the carbon. So let's try to see the structures. You can see here positive charge on the carbon, nearby hydrogen has inductive effect is equal to 0. So it is not either increasing the positive charge or it is decreasing the positive charge. But when you are taking the next compound, it has chlorine present. What does chlorine have? It has a minus I effect. So it will attract the electron in this direction. Electron is moving in this direction means positive charge here is increasing. You can see I am zooming, maybe positive charge would increase. Charge increases, stability decreases. Okay. Now here in this structure you can see two chlorine atoms are doing the same thing, sir. Two chlorine atoms are doing the same thing. So what will happen again? I can easily say, 1 minute, something happened. Okay. I can easily say two chlorine atoms are pulling the electron in this directions. So the positive charge would increase very fast here. So stability will decrease very fast here. In the third one, you can see three chlorine atoms are pulling the electrons. So charge would increase very fast because electrons are moving in this directions, means the deficiency is increasing here. The positive charge is increasing here. So stability would decrease very fast. So I can say the most stable one is A, then B, then C, then comes D. Okay. So my answer would be A greater than, B greater than, C greater than D. This would be my correct answer. So I can say here, with the inductive effect, I am trying to get the correct answer. Clear? I hope it is clearing for you, right? Clear for you, right? Okay. Now we have more questions into effect. There are more questions. So we have completed around, you can see around 56 pages we completed. 56 pages out of 130. So we have more questions coming out here. I can just scroll down and say there are more questions coming into picture. We need to solve all these questions to get a very good score for NEET exam. So I'm stopping here today. I think this is sufficient for today. Then we will continue in the next week, we will create more videos frequently, maybe in the coming days. And please support us. If you are not understanding any particular area, please put it on the comment box. And if you feel like, sir, we are not strong in organic, feel free to contact Brainiacs Classes. We will deliver you the best lectures and we will sit with you to make you understand organic chemistry. Okay, so signing off, Riaz Ahmed from Brainiacs Classes. Thank you for watching the video patiently, and if you have any doubt, feel free to put it in the comment box. Okay, yeah, thank you.